Today's lesson is 5.3, Solving Rational Exponent Equations. When we're going to go ahead and solve a rational exponent equation, we first need to isolate the variable. Then we need to eliminate the exponent by raising it to its reciprocal power. Let's start with determining if a value is a solution to a rational exponent equation. So in example 1, we're asked if x equals 9 is a solution to this rational exponent equation. All we're going to go ahead and do is take this 9 and substitute it right in for the variable x and see if we can get 35 for an answer. Let's go ahead and give it a try. So 2 times 9 to the 3/2 power minus 19. I want to see, does that equal 35? Okay. I'm going to go ahead and show you a cool feature that I found out on Desmos. And I'm going to go ahead and multiply the 9 to the 3/2 power. So let me go ahead and switch over to Desmos. I'm going to click up the keyboard. And I don't know if you knew this, but Desmos is really a calculator as well as a grapher. So I'm going to go and hit 9, and then I'm going to raise this to the AB power. And this gives me my exponent. And I'm just going to go ahead and put in the 3 divided by 2. Bingo, look at that. Desmos is showing me that 9 to the 3/2 power is 27. I'm going to go ahead and go back to my good notes, and I'm going to say 2 times 27 minus 19. 2 times 27 is 54. 54 minus 19 is 35. I got my answer, so my answer is yes, x equals 9 is a solution. All right, now let's go ahead and see how I would actually solve this equation. So I'm going to go ahead and start by drawing my line through the center, and I'm going to then highlight the variable x, because remember my first step is to isolate my variable x. I see the exponential power of 5/2, and then I see the 3 in front. The first thing I must do is get rid of the 3. Anything that's in front of the variable or anything that is after the variable, added or subtracted, needs to get rid of before you can raise it to the reciprocal power. So what we're going to do is we're going to divide by 3, both sides, giving us x to the 5/2 power equals to 32. All right, now we're going to go ahead and raise this to the reciprocal power. I think I need a little bit more space, guys. Sorry. There we go. There we go. That's better. And now I'm going to go ahead and raise this to the reciprocal power. The reciprocal means I'm going to keep the fraction, but I'm going to change the denominator and the numerator. So I want 2 over 5, 2/5. This is going to give me x, and I'm going to go back to my Desmos calculator to show you what the answer is. So let's go back to Desmos real quick. Let's get rid of that one, and it's 32 raised to the 2 divided by 5 power. And there's my answer right there. I don't even have to press equals. 4 is my answer. How cool is that? All right, let's go ahead and take a look at our next one. So remember, you always want to start by drawing your line through the equal sign. Let's see, I can do that better. There we go. You want to highlight your x variable, or y or u, whatever it is that Alex is using. And you want to start isolating. Before I can go ahead and take this to the power, I've got to get rid of this, then this, and then I can go ahead and get rid of the power. After I get rid of the power, I'm going to have to get rid of the 5 because it's inside. So let's go ahead and start. I'm going to subtract 48. Negative 2, x minus 5 to the 3/4 power. Negative 202 minus 48 gives me negative 250. I'm now going to divide by the negative 2 because I have to get rid of whatever's in front next. So it's behind, front. Now I'm going to have to get rid of the power. So there we go. Now I got to get rid of the power. This is going to be 125. I'm going to raise this now to my reciprocal power. So I'm going to flip the fraction and put it 4/3. 4/3. I'm going to go ahead and flip the power. I'm going to go over to Desmos and I'm going to put that in so that I can see what 125 to the 4/3 power is. So let me have you watch one more time. Let's X that out. 125. I'm going to press over by the ABC part. I'm going to press the A to the B button. And now I'm just going to go ahead and put in my fraction as division. 4 divided by 3. 625. Oh my goodness. 625. I'm going to add 5, because remember we want to isolate that x value. X equals 630. Wow. Now that concludes our portion of solving rational exponent problems today. But what I did want to show you is this last example, and you are going to have this question on your Alex assignment. This is the one where we're going to find the inverse. So we're going to consider this function, and what Alex is going to give you is a square root function. And they're going to go ahead and limit the domain. So they're showing me the domain is negative infinity to positive 4, or x is less than or equal to 4. These are the negative values from 4 to negative infinity. And they want me to find f of negative 1 of x. They want me to find the inverse of this function. Okay, and then they also want me to state my interval domain. Now, as we learned in the first lesson, the inverse of a square root function is going to be a quadratic function. So to find my interval notation for my domain, I'm going to go and look at my Desmos graph. Okay, so let's start with trying to remember how to do the inverse. If you go back to your notes from last week, from 5.1, the first step to find the inverse is you're going to take this function right here and you're going to write it as y equals the square root of 4 minus x plus 6. Now we're going to go ahead and do the inverse step. To do the inverse, I'm going to go ahead and switch the variables x and y. So the letters are just going to get switched. I'm going to start by saying x equals, and I'm going to put 4 minus y plus 6. I want to get this new y variable by itself. I want to isolate it. So I have to stop and think what's bothering it. Well, I see a 4 right in front of it. I see a minus right in front of it. I see a square root, and I see a plus 6. Here's how it has to work. So what you have to do is you have to take whatever is outside of the square root and move it first. So that would be the plus 6. So I'm going to first find whatever is outside the square root and I'm going to move it. If there happens to be anything in front of the square root, I need to divide to get rid of it. Okay, but this one only had something outside at the end being added to it, so I just subtract it to get rid of it. All right, there we go. Now I am simply left on the y side. I keep highlighting it so that you guys can keep focusing on it, okay? I want you to keep focusing on it. It is alone with a square root, so let's get rid of the square root. To get rid of the square root, we would simply square. What I do to one side, I must do to the other. Remember, on this side, when you square it, you're really doing x minus 6 times x minus 6. That's what this really means. So you're going to go ahead and grab your little box that we talked about when we did complex numbers, and you're going to put x minus 6 at the top, and you're going to put x minus 6 on the side. Remember, you're multiplying the side times the top, and they're all rectangles, so the properties of rectangles hold true. Negative 6 times x is negative 6, negative 6 times x is negative 6, and negative 6 times negative 6 is 36. I just went ahead and did x times, right? Okay, that's all I did. Then I went ahead and just like with our complex numbers, or I'm going to go ahead and I'm going to add these two together because they are my like terms. And what I end up with on this side is x squared minus 12x plus 36. On the other side, I end up with this. All right, I've got to get rid of the 4 next. And the 4 is going to combine with the 36. The 4 is going to combine with the 36. Ooh, I'm running out of room. Oh no. Oops, I forgot the x. Plus 32 equals, it's not quite y. I couldn't get that negative to cancel out. To get that negative to cancel out, I am going to think of it as negative 1, which means I would divide by negative 1. I have to divide everybody by negative 1. Okay, that would make my negative 1 disappear. What happens on this side when I multiply by negative 1? I just change my sign. I simply change my sign. So my y is equal to negative x squared plus 12x minus 32. This is what I get when I divide by negative 1. Now, the last step is to take this y and change it to the function inverse notation, which is this right here. In fact, I'm going to go back and show you guys that I did divide that by negative 1, just in case. There we go. And so what am I going to put right here in this first blank? I'm going to put negative x squared plus 12x minus 32. This is what's going to go in this first blank. Now for the domain, what I'm going to do is I'm going to go over to Desmos and I'm actually going to graph this function. But what I need to be thinking of is I need to figure out where this should be, okay? Where should my restriction be? So let's go to Desmos. Let's get rid of that multiplication we did and let's go ahead and put in this function. X squared plus 12x minus 32. There it is. Now, what we need from this graph is its vertex. 6, 4, 6, 4. Now, the inverse to this, how I'm going to use the domain here to find it is I'm going to take this this vertex point of 6 comma 4. The domain is attached to the 6. The domain is attached to the 6. And the restriction on the one that they gave me for the square root, I am going to do this one to the right. It's always the right side of the graph. So my graph is going negative, is at 6, and then it's heading towards the positives. Um, I would actually not see the graph right here. This part of the graph actually doesn't exist because it's on the left side of the vertex. But this part over here does exist because it's on the right side of my graph. So it's always the right side of my graph that counts when I'm doing my inverse of a quadratic. So 6, and if you look at this point that I have right here on the right side, it's positive 8. It's bigger than it, so I'm heading towards positive infinity. Let's go back to our graph and let's go ahead and fill that out. I'm going to change my color ever so slightly so that you can tell which one goes in which blank. But you would go bracket 6 because it is the vertex and it does exist. So you want to make sure you use a bracket, comma, infinity, and take a look. Alex has the 2 infinity symbols for you. This is the null set where you would say there's no domain. And then you would put a parentheses. So you're going to want to do this by picking this one first, then typing in your 6 in the first blank, and after the comma, going ahead and putting in the infinity symbol. Hope this helps.